Good morning, campers. Today we are continuing Unit 7. We are doing 7.3 logarithms and logarithmic functions. Okay, so to introduce this, we're going to go back and talk about our exponential functions. So we have consider the function f of x is equal to 2 to the x. We're going to find its inverse and graph both functions. All right, so if I set up my table. Alright, so you guys just did this, so this isn't too bad. So I'll just do simple ones. 0. So 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. Alright, so 0, 1. 1, 2. 2, 4. Alright, remember these have an asymptote. Exponential functions grow fast or decay really fast. So this is f of x equals 2 to the x. So the inverse process, I have to change f of x to y. I have to swap x and y. Alright, and as of right now, we don't know how to do this, but we're going to use logarithms to solve these. So if I do my table, alright, so I got to plug in numbers for y. So if I get y to be 0, x is going to be 1. If I plug in 1 for y, x will be 2. Plug in 2 for y, x will be 4. So we have x is at 1, 0, 2, 1, 4, 2. Alright, and these, instead of the asymptote being the x-axis, the asymptote is the y-axis. So this is x equals 2 to the y. Log. Alright, that's what we're doing today. So these are the graphs of logarithmic functions. Alright, so exponential functions look like the orange line, and logs will look like the blue line. Okay, so follow along, and it shouldn't be too bad. First thing we need to know is define what a logarithm is. So if we have y equals b to the x, then the logarithm to that is log is base b of y equals x. So log base b of y equals x. That's how it's read. Okay, so we're going to take our logarithms, or these exponential functions, and write them in logarithmic form. So what I want to do is label my y, my b, and my x. So for example 1a, y is 3,375. The base is 15. The x is 3. So log form, remember it's log base b of y equals x. So substitute in what I have. My base is 15. 3,375 is equal to x, which is 3. So that's converting from exponential form to logarithmic form. Alright, so if you Google scientific calculator or a graphing calculator, you can press the log button on there. Or if you have a graphing calculator, that should help you. So for b, same thing. Y is 2. The base is 4. The x is 1/2. So log base b of y equals x. So log base 4 of 2 is equal to 1/2. So far, so good. Just plugging in and rearranging things. Example 2, we're going to do the flip. So we're given in log form, now we need to go to exponential form. So we need to go to y equals b to the x. Remember that log base b of y is equal to x. Alright, so y, x, and b. So y is 8, b is 2, oops, wrong spot. B is 2 and x is 3. So we have y equals b to the x. So y, b to the x. So I have 8 is equal to 2 to the third power. And if you think about it, 2 cubed is 8. So that is definitely true. Alright, and then for b, y equals 1 to 56th. X is -4, and b is 4. So y equals b to the x, 1 to 56th is equal to 4 to the -4 power. Alright, and if you think about that, it's 1 over 256. Can't have negative exponents, so it becomes 1 over 4 to the 4. And 4 to the 4th power is 256. So, they're equivalent statements. Alright, so we are going to solve or evaluate this logarithm without a calculator. Alright, but you should have a calculator. You can Google it. You can use your photo math that I know you all love using. Alright, so to evaluate it, we're going to set this equal to y. So, boom, equals y. We're going to convert to exponential form. Alright, so I have y equals 4. X is equal to y. As weird as that may sound, it's just a placeholder, so don't get wrapped up in x is y and all that. My base is 16. So y equals b to the x. So for y, I have 4 equals my base of 16 to the x, which is now y. Okay. So now we need to do, like we solved exponential equations, we need to have the same base. Okay, so I'm going to use base 4 here. So I have 4 equals 4 squared, because 4 squared is 16, y. Alright, I'm going to continue solving it down. So I get 4 equals 4 to the 2y. Remember, that's a 1 right there. Drop the exponents, or drop the bases, solve the exponents. 1 equals 2y. So y is equal to 1/2. Alrighty, that's how you evaluate a logarithm without a calculator. Alright, so graphing logs. Okay, so these are the inverses of exponential functions. So my range will always be this, and my domain will be whatever my vertical asymptote is to one of the infinities. Excuse me. Alright, so like as I said before, instead of our x-axis being the asymptote, it's my y-axis. Vertical asymptote. Now these will shift when we have our standard form. Okay, so moving on. I'll make a Desmos video and post that as well. Alright, so simply I'm just going to create a nice quick little table. And when I have the table open, I'm just looking for numbers that fit nicely. So I'm going to use 1, and I'll get 0 because I'm looking at the table right now. 5 will give me 1, and then 10 will give me 1.4. So we need at least 3 numbers to help us plot these. My vertical asymptote. And then I have 1, 0, 5, 1, and 10 and 1.4. So let me just draw a curve. Write our asymptote going down, and it looks like that. Alright, so remember, inverses are just a reflection across the line y equals x. So if I reflect it across this line, y equals x, right here, it would be the exponential function that goes along with it. Sorry, I'm trying to undo my beautiful dotted line. Alright, domain is from my vertical asymptote, which is 0, and we're going to the right, so that's positive infinity. My range, all real numbers, negative infinity, positive infinity. Remember, this is interval notation. Alright, for B, again, using the table, using the calculator, I'm going to use 1, 3, and 9er. 1 gives me 0, negative 1, negative 2. Vertical asymptote. So I have 1, 0, 3, negative 1. And this is going a different direction because of this 1/3 right there. And then 9, negative 2. So now we go like that. The 1/3 makes it a decay instead of a growth. Just like exponential functions. And my domain is for my vertical asymptote of 0. The graph's going to the right makes it positive infinity. My range, it goes up and down in all directions, so it's all real numbers. Negative infinity, positive infinity. And now the standard form log. Okay, so we have our A, H, and K. These things haven't changed. H is still our horizontal shift. Remember, it's always opposite. And we have our K, which is our vertical shift. And it's always the same. If A is greater than 1, we compress. If we are in between 0 and 1, like a fraction, as we value it stretches. And a negative A will reflect over the x-axis. So same things, A, H, and K all do the same for all types of functions. Alright, so moving on to example 5. So my A is 3, my H is 0, my K is 1. Alright, and this, my H will be my vertical asymptote. So I'll create my little table. Remember, I'm just plugging this in the calculator and looking at the table. So I would use Desmos for you and use the table. So when I see 1, I get 1. You need 3 points. So I pick somewhere in the middle. 4 gives me 2.8. And then 10 gives me 4. So vertical asymptote is 0. And then 1, 1. So it's shifted up 1 unit. The last problem was at 1, 0. I have 4 and 2.8. And then 10 and 4. There we go. is from your vertical asymptote, which is still 0, and goes to the right, positive infinity. Range, always the same, negative infinity, positive infinity. For B, A is 1/2, H is 3, K is 0. That's my vertical asymptote, so I'm going to go to 3, prep it ahead of time. So there we go. Using my table, I'm going to pick points that are to the right of 3, otherwise we'll get undefined. So I'm going to use 4, and that gives me 0. 7 gives me negative 0.5. 10 gives me negative 0.70. Again, I'm only picking 3 numbers because it helps me graph it. I'm kind of picking, if I'm looking at the table, I'm kind of picking numbers that fit nice. All right, so 4, 0 is obviously easy to graph. 0.5 is not bad, and negative 0.7, well, that's what I have. It's close to negative 1, but it just kind of gives me an idea what the graph should look like. So I have 4, 0, 7, negative half, 10, negative, there we go. Boom. Domain, vertical asymptote is 3, so parentheses because it won't touch 3, and then goes to the right to positive infinity. Range, it touches every single y value. Okay, so it goes from negative infinity to positive infinity. Alright, and then we have C, A equals 2. H is negative 1, opposite of opposite, right? And then K is negative 2. Vertical asymptote's at negative 1. So my table, I'm take numbers that are greater than negative 1. So 0 gives me negative 2. 2 gives me 0. And 8 gives me 2. 3 very nice and easy numbers to graph. 0, negative 2, 2, 0, and 8, 2. Oh. A little rough on the curve there, sorry. Alright, domain, vertical asymptote is negative 1, then to the right. Range, negative infinity, positive infinity. Okay. So we have the Richter scale. So I was reading. The Richter scale measures earthquake intensity. The increase in intensity between each number is 10 times. For example, an earthquake with a rating of 7 is 10 times more intense than one measure of 6. Than one that measures 6. Sorry, typo in there. The intensity of an earthquake can be modeled by the function f of x equals 10 to the x minus 1, where x is the Richter scale rating. So, for example, 6 part A, the world's largest earthquake with an instrumentally documented magnitude occurred on May 22nd, 1960, near Valdivia in southern Chile. It was assigned a magnitude of 9.5. Okay, we need that. It is referred to as the Great Chilean Earthquake and the 1960 Valdivia earthquake. Find the intensity of this earthquake. Okay, so easy. F of x equals 10 to the x minus 1. F of 9.5, we're using that for x, is 10 to 9.5 minus 1. 10 to the 8.5 power. I guess you guys can see my calculator, hopefully. Maybe. Do I have one? Oh. Well, I'm stumped. I don't have a calculator in front of me. My child is borrowing my phone currently, so can't even use that. Ten to the 8.5. And the f of 9.5 is equal to 316,277,66.02. So add some commas in here. So it's 316,227,766 is the intensity of that earthquake. Now we're going to find the inverse of this intensity equation. So say y equals 10 to the x minus 1. Swap x and y. So x equals 10 to the y minus 1. Alright. And currently there's no way to solve, so we are done. Till the next lesson. Probably come back to that. Alright. So enjoy the homework and have a great day.